And gentlemen, Weather Brains, episode number 956. Goodness, we've done a lot of these shows. This is for Monday, May 13th, 2024. This is the pre show, the magical time where we share boring personal stories, humorous anecdotes, and from time to time we say really outrageous things. So if you're looking for the show content, move the slider over about 9 minutes. For those watching live, we'll start at the top of the hour. So let's see who we can find here. Bring everybody in. Hopefully, our Oklahoma correspondents can join us. You know that they've had a rough ride. The last two Monday nights, we basically had severe thunderstorms in Oklahoma that's knocked out Rick Smith and James Adelot. Kim was able to get on the show some last week, but hopefully they're back. Michael, can you see us okay? Can you hear us okay?
I can see you, but nobody else. But maybe that's the way it's supposed to be.
That's the way, as Walter Cronkite said, that's the way it is.
That's right.
Nobody even knows who that is anymore.
I know, I know.
Yeah, I don't believe you. You probably heard of him, but you've never. I am old enough where I watched Walter Cronkite. In fact,
Well,
this is embarrassing.
you
When
might be
I
about the same
started
age as
doing
me.
when I started doing this for a living, Walter Cronkite was still doing the evening news on CBS. So
Really?
I
Yep.
started in 1978, and he actually came on before I came on. The
Really?
6 o'clock news was at 6. Walter Cronkite came on at 5:30.
Right?
And this was the little CBS affiliate in Tuscaloosa, Alabama. And at 6 o'clock, Eyewitness News
Yeah.
would come on.
Nice.
But this was many, many eons ago. But no,
I
you'll see
remember.
all the other creepers showing up here in a few minutes.
Yeah, yeah. No problem. How's life treating you?
Uh, Good. We have had the easiest severe weather season in a long, long
Really?
time.
Yeah, in the
As bad
southeast.
as it's been in, Oklahoma and
Right.
Kansas and Nebraska and Iowa, as bad as they've had it, we've
Yep.
had it just easy as could be.
Nice.
So
Nice.
I just have a really bad feeling about the hurricane season. Um,
Yeah, you look
you know,
at I'm down on vacation in Florida and you walk in the water and it just feels like it's 95 degrees or something, on the Gulf side. So yeah, the water is
yeah,
definitely
it
warming.
just seems as though the pump is primed. The only thing I see a lot of dust, a lot of desert air out there, but other
Yeah.
than that, it just looks like it's going to be a shake and bake kind of season. So
Yep. Yep.
maybe we just needed the break from the tornadoes to deal with the hurricanes. We'll see.
By the way,
But
can
it's
you hear me just fine and all that? Do I look okay and all that kind of stuff?
yes, sir. Clean as a whistle. Audio good, video good.
Awesome.
Bill, let's give him an A plus.
An A plus.
Hey, Bill.
Third, hey, Mike, third time's a charm, right?
Yeah, exactly. Exactly.
Just as long as we got
Um,
rid of Google Hangouts, Mike, it used to be such a disaster.
and
Every
we
week
learned
was like a mystery.
with Google Hangouts, it was an adventure. The higher the IQ, these PhD, the upper end PhD Einsteins could not figure it out. The low
Really?
levels could get on there, but the smarter they were, they couldn't figure it out.
Oh,
So we
I
morphed from
developed
Google.
ulcers on
Google,
top of ulcers during that
yeah,
period.
we morphed from Google Hangouts to Zoom, which is a much easier platform to
Yeah.
deal with here. So,
Yep. Yep.
Yeah,
and,
I
I,
think we're
and during
batting a
COVID,
thousand with
everybody
Zoom.
had to use it. Everybody had to use it at some point, I think. So
Oh yeah. Yeah.
people just
Yeah.
have some experience here. Um,
Yeah, a lot of the bigger companies are going like our Spire is going to Teams now, which is of similar quality, I think. But I think I still like Zoom better.
Some reason I
I
can't
just,
use Teams on the. I'm sorry, Don. Bye bye. It works fine in a browser, but it doesn't work on the Teams app, which is
Really?
weird to me.
Yeah. Yeah.
It just
I
be
still
my
say
Mac.
Microsoft is a plague to society, and I avoid at all costs. I will never forget the pain I endured. This was in 2006, early 2006, which I think was the year we started this show here, where I had a video project. I had worked for a long, long time, and it blue screened me, and I was not able to recover the data, and my heart was crushed.
Really?
By the end of the week, I went down and bought my first Mac, and that ended my Microsoft days. So I don't
There
know.
goes all those Bill Gates dollars we've been trying to get for the show.
yeah. About to say, well, we'll never get Microsoft as an advertiser here, but that's all right.
I would agree.
Tim Cook is an Alabama guy. Maybe he'll come on the show.
There you go.
In fact, I think
Hey, why
I think
haven't
he
you
ought to
done
just
that
come on the
already,
show.
James? That's
I think
low hanging fruit.
We ought to get him on the show. And he's from Robertsdale, Alabama, which is in Baldwin County.
Baldwin County, can't beat that.
Just north of Gulf Shores. And he went to school at Auburn University. And we used to email a good bit back when he was the COO, when Steve Jobs was alive.
Really?
But I have.
He's a little busy these
him.
days.
Yeah, he got some things on his plate.
He'll always take your call, though, James. Did you see that article about Kurt Jarvis in today's AL.com? Do you remember him, James? Played football at Gardendale.
He's a pilot.
A pilot. That's right. He's a Delta pilot. About to graduate up to the 350. And I just flew a 350 to Los Angeles last week, and it was so much fun.
No, that was a good piece. Very good piece.
It really was a good story by Rick Carley.
But no, I'll see if Tim will. In fact, after April 27, 2011, one of the first people to reach out was Tim Cook, and he just wanted me to know off the record that they were, making a big donation to some of the relief funds, and
really,
I thought that was kind of cool. Yeah.
Mm-hmm.
But since he's become the top dog, I have not disturbed him too much.
Not for this silly show.
Yeah, Jen, what's on your mind?
Hello. Oh, I'm just glad it's fairly quiet until I looked at the Baton Rouge radar. And
I
like,
know. They look like an
oops.
army of advancing tornado warnings here.
That is nasty down there. No, I'm good. I'm bummed. I'm sure we'll talk about this. I did not see the aurora up here.
I didn't either.
I missed it. I missed that really good window. Oh, man, I was bummed. And I was still looking at like 11, 12. I was still looking for something, but I missed the whole thing. So at least it was all over Twitter and, photos everywhere. It was so amazing though. I just see some of the photos as far south as Key West,
Puerto Rico, even I heard.
Or Puerto Rico,
really?
Yeah.
Really, I didn't know you were that far south.
Yeah,
I looked at James's Twitter feed, and it looked like a roulette wheel going by.
Oh yeah. It was quite an evening, and the initial forecast was a G4, and G4s just don't. Yeah. I've been through oodles of these things, and they don't produce anything at this low latitude down here. And it just immediately ramped up to a G5. And before you know it, I was getting, pictures at the rate of 20 a second.
Really?
And I'm thinking, all right, this is a big deal.
What time was the first one you got, James?
Oh, I can't recall. I'd have to. Here's the sad part. I would imagine there's over 50,000 in here, and I will never be able to see them all. And I would say this is the first event where I know I'll never be able to see them all. And I know there's some absolute gold in there, just some incredible content. And it was just, it was that kind of an evening. And I'm glad people were looking up, and I'm glad they caught it, because I honestly, in the morning when the G4 was forecast, I didn't think anything would happen.
Yeah.
I kind of poo-pooed
saw those headlines, Aurora in Alabama. And I'm like, yeah, right.
Yeah, and it's a boilerplate thing. It's just like standard boilerplate material from the Space Weather Prediction Center. Every time there's a G4 alert, you might see the aurora as far south as Alabama. And, please take that out, because I'm just inundated with all these requests and questions. And this time it actually happened, but again, it was a G5. All right, well, let's get the right. For those that are watching, that's the line that's producing some nastiness approaching Baton Rouge, Louisiana. I'm sure, Rick, you're glad it's not you tonight. It's somebody else. Yeah. All right. So it's the top of the hour. Let's get the thing going here. But welcome to those that are watching on the television side. And here we go. We got track 1 and 2 recording. And here we go in 5, 4, 3, 2, 1.
You've heard James say it a million times. Respect the polygon. At Weather Call, we call, text, and email you when you're in the polygon. So in a way, we make the polygon better. With solutions for personal use, businesses, schools, pools, playgrounds, and RVs, there's a Weather Call solution that's right for you. Check us out at weathercallservices.com.
You're listening to WeatherBrains. They're kind of a big deal.
Well, you heard that from none other than Bill Curtis. Kind of a big deal. Ron Burgundy, WeatherBrains, episode number 956, Monday, May 13th, 2024. Goodness gracious, it's been a few weeks here. So welcome. We have had an amazing display of the aurora, thanks to a geomagnetic storm. We'll talk about all this as we go along here, but I'm just glad to see our Oklahoma correspondents back online with us. Everybody's in the house. So let's start with Rick Smith. Rick, is your voice back? Have you recovered at all?
I'm good. Yeah, we've had a whole weekend with no tornado warnings. Well, I don't think so. Anyway, pretty much no severe weather for a weekend, and yeah, I think we're rested up, enjoying I hate to even talk about it, but the lull in activity at the moment.
Lull. Well, again, thank you for your work. I know you deal with trolls and haters and know-it-alls and everybody else, but just understand we appreciate everything that your office did and what you did. So thank you.
Thank you.
We just don't say that enough. And James Adelot, thank you. I watched some of your coverage. You were on it. You were all over it.
Yeah, that was a bad night. Wish we'd have never had to do any of that.
Yeah, we had a client with a hotel in Bartlesville, and I was calling him about 20 minutes out. Unfortunately, it veered to the left a little bit, but it still got the Hampton Inn. And I don't know. I figured the Hilton Garden Inn made it through fine in town, but the Hampton took sort of an indirect hit, lost part of its roof, I heard.
Yeah, some of that video, there was a family from Brazil there. It was their first night in the United States. So they were kind of in the lobby, not quite sure what to do because it was not a Bill Murray hotel with the instructions up front and center. And then there were a couple employees in the parking lot that basically just last minute dove back through the door when it all started coming apart. But yeah, that was, the race was on whether or not the big cluster of thunderstorms would get to that supercell, and that's what happened. You just never know how long that's going to take, because sometimes these thunderstorm supercells like that are producing. Organization at that level takes a little while to go away.
Well, I was watching you from Los Angeles, James. Your calm demeanor, I mean, your approach was exactly what I expected from you, but it was interesting to watch you in action. So that was I wasn't happy about it, or it wasn't a treat, but it was kind of an honor to watch you.
Yeah, it was. I'm lucky to be surrounded by the team that I have. It sure makes a lot of things easier.
Let's bring in Dr. Kim Cloko-McLean. Kim, have you rested up from the wildness of recent weeks?
Oh my gosh, I know that I wasn't even doing the forecasting and warning and on-air advising that you guys were doing, but I was exhausted. So I can only imagine how you all feel. It's just been a long spring. It's already been a long spring, and we're only just getting to the middle of May. So yeah, good times around here. But I was very anxious watching your coverage. Okay, James, because my husband, his folks are in Bartlesville, and the rotation, the tornado when it was in Barnstall, was very much going right toward them. So if the line hadn't hit, they would have been hit. And instead, it was the golf course just up the road from them. So yeah, very, very anxiety inducing. And it was just a very, very anxious day. So thank you guys so much for everything that you did. It's been a lot. So I support, all of the national centers. And so the SPCs, of course, had a lot going on, and they have done a remarkable job through some very, very tough forecasts. And at the same time, Swipsy, the Space Weather Prediction Center, sure has had a couple days, haven't they? So it's actually pretty remarkable. I've had the chance to talk with them some this spring. We've been talking a little bit about different risk communication practices that they could try and other things. And I've been watching the various press releases. I haven't bugged them yet, but I've been watching all the things that they've been saying to the media, and it's just like, oh, they're doing such a good job. They've really made their operation great, which I mean, it was already great, but they just made it that little extra bit wonderful that is so good for what's going on right now. And I'm so excited, Mike Iles. Good to see you too. I'm so excited to have you in this show talking about satellites, among other things, because boy, do I imagine you have a lot of interesting things to share with us.
Thank you. I'm very excited to be here today.
Yeah, it's going to be a good show. We'll formally introduce Mike here in a second. Let's bring in Jen Naramore. Jen, you deal with everything. You deal with everything,
Yeah.
so hopefully it's a little calmer for you now.
It is, yeah. It wasn't too bad for radio. It's just a lot of radio forecasts and what have you last week. But for Tornado Talk, we watched current weather is about to become history. So we're always watching the current weather to see what's happening and watch these storms unfold. And it really helps us with our writing. And we may go back and write some of these events. And so I as well was watching James Ailadot's coverage. It's the first time I'd ever watched you at length. And I just thought it was great, James. And I agree. Your demeanor is so calm but urgent. It was the right tone for what was happening. What was a complicated forecast day. And I also on Tuesday had stuff for me. And so I'm sitting here basement time for the third time or not. I'm watching it. And then on Wednesday, it was Alabama's turn. And we were watching stuff for Zach. At one point, he was directing his family in Scottsboro. And of course, they had a tornado come through. And then he was in Huntsville trying to figure out what he was going to do. So he ended up leaving his apartment and then navigating his family. So, we're just a family at Tornado Talk. We're always helping each other and making sure we're reaching out. And then it's through our people in the Discord server, they're reaching out to their family. So it's really been kind of a neat community that we've built to talk about some of these events. So I'm glad for just a small break before we kick it back in this week.
Let's go to Dr. Neil Jacobs. Dr. Jacobs, do you feel left out?
Not really.
Active weather here.
I'm kind of enjoying being out of the loop. But Kim was sending me texts trying to keep me up to date. But it's I went from one swamp to another, and I'm up in DC now. I wish I wasn't in the loop as much as I am here, but it is what it is.
No. You're in the circle of the Washington, D.C. inner circle of trust. Very few people are in that circle, but you are. So, and we're thankful it's you, not us. When you're in the circle, it goes round and round and round. Hey, Troy Kimmel, what's going on down in Texas?
It seems like everyone except for Neil has had the chance lately. And, up till last Thursday, I was pretty happy. This last week is last week of classes at the university. And I was in the Emergency Operations Center, Rick, at UT from 7 a.m. to 11 p.m. on Saturday with our commencement. And we lucked out with that. But last Thursday night, we didn't luck out with what we're going to be doing. Paul, you're Rick and his group down in New Braunfels will be having to, I think calipers are in hand now. We got some hailstones out near Johnson City of 6.25. That was estimated. That's what the local storm report carries now. But the largest hailstone in Texas history is 6.4 from Hondo, Texas, back in 2022. So they're going to be checking that one out in the next couple of days. Paul and his group at the Weather Service and the Climate Records Review Group, the group that does that, Rick, are going to be hanging out, watching all that. And then the windstorm that came with that. I don't know if anyone was watching that cell as it moved down last Thursday night into San Marcos, Texas. But go back and look at that. So impressive. The storm wound up and came through San Marcos. I think we had Paul Ura was telling me at New Braunfels that storm, as it wound up, I think it's 600 feet off the ground, there was a 90-mile-an-hour wind. And That was pretty evident. That was above San Marcos, Texas. And if you go to San Marcos today, you will see that in the wind damage in the city. It's been pretty widespread. So everyone's had their stab at it. And you know what's next? This spigot will shut off at some point, and then we'll be 137 again in Austin, come here in a few weeks. So summer is not all that far behind.
And I've noticed the Canadian wildfire smoke is back.
Yeah.
And,
Yep.
Of all places, my little June getaway, my wife and I were going to the Canadian Rockies. it's great. You're going to inundated with wildfire smoke, but maybe it will disperse by then. But forget. And by the way, the working show title is from one swamp to another. That is a great show title. Neil, thank you for that. But Bill Murray is back from his Beverly Hills adventure, the Jed Clampett special. So, Bill, welcome back, and let's bring in our guest.
Yeah, it was definitely Jed Clampett like that was for sure. But last Monday night, I was sitting up in the Marriott airport at LAX and watching all the coverage and everything going on. But like the time is so weird when you're out there, because it's like 7 here was like 5 there, and by the time all the action was going, WeatherBrains was already over by the time I got back from my pub crawl. So anyway, it was interesting to watch. But tonight we have an old friend of the show and a friend of all weather fans. He recently joined Spire, a weather forecasting company that utilizes advanced satellite technology and data analytics to produce highly accurate, timely weather forecasts. Not the first time we've had someone from Spire on the show. We visited with Chris Manchek on show 808. I always like the titles, because we put a lot of effort in these titles. That one was called Peanut Butter Sandwich and Sweet Tea. I have no idea what that means, but that was in July of 2021. But our guest weatherbrain tonight made an industry announcement on this show when he appeared on show 303, which is called "The Fee is a Six-Pack and a Can of Viennas." So I know what that was about. In November 2011, he appeared again on show 751 a few years later. I guess we've been doing this so darn long, and it was, James, see if you remember what this was. I'll just call it John. I'm not sure what that meant. Maybe Mike remembers. But he's a seasoned meteorologist with extensive experience in weather technology data analysis. He co-founded Weather Decision Technologies, which became a leader in providing decision support before it was acquired by DTN. And currently he's a key figure at Spire, focusing on harnessing all that satellite data. Michael Iltz, welcome back to WeatherBrains.
Oh, well, thank you so much, Bill, and everybody here. I know all of you, and great seeing everybody again. And it's great to be on this show. And I was talking to Bill last night, and I said, what a great service you guys have done since 2006 for the weather enterprise. It's just amazing that you could go that long and keep going every single week. But I'm very impressed, and I'm very happy to be on the show for the third time for sure.
Yeah, we'll go ahead and fit you for a robe after this one tonight, Mike, and then you're just like an unofficial WeatherBrains member. But yeah, it's really fun, and thank you for saying those nice things. It's all cause of Span. I can't imagine anybody else that would have gotten all of us out each and every Monday night for 18 years. It's hard to believe. I talked a lot about your background, Mike, but tell us about how you got interested in weather. I don't remember all the way back to show 751 or 303. I don't hardly remember what I had for lunch today.
Well, I don't remember back that far either. So, but I grew up in Minnesota, and the real story was in Boy Scouts, there's a weather merit badge, and I got the weather merit badge. I made the rain gauge. I made some weird cheesy anemometer, and I took measurements for 2 months or something like that, and that just got the spark going, honestly. And always being good in science and math and those kind of things, and not really wanting to be an engineer, I decided that weather is what I wanted. That was probably when I was in 7th or 8th grade, honestly, and just pursued it from then. And I went to the University of Minnesota for 2 years. They did not, and they still don't, I don't think, have a true weather program. So got south. That was one thing, the cold, and I was a golfer at the University of Minnesota, and I just needed to go south and play golf and be in the warm weather. But obviously OU is one of the premier programs in weather, and got down to Norman and found a lot of exciting storm chasing and a great program, and got to meet and make a lot of friends. And the weird part, I just left, moved my family out of there about a year ago to the Boulder area now in Colorado.
Well, so that's got to be a great place to live. Could do with a few less wildfires probably, and all that sort of stuff. But I understand, that's just a great place to be for sure.
Oh yeah. I
I
mean, Boulder and
remember.
Boulder and Norman have been for decades the two places in the United States for weather, weather basically, the weather enterprise. So you got research and private sector and the public sector all together, which is an amazing thing. So both places are great.
So Mike, where were you before WDT, and how did you end up there?
Well, I got my master's degree working with Dick Dobiak and Dusan Zernich at the National Severe Storms Laboratory, and from right from getting the master's degree there, and I just jumped right into the Severe Storms Laboratory, and I won't say how long, but it was like 18 years I was at the Severe Storms Laboratory too, counting from college all the way through, and we did some amazing things at NSSL. I mean, I took over a team and grew it, and ended up being the assistant director of the lab for the last 7 years while I was there. And but the great thing is we did a lot of the algorithms you still see on the NextRad radars were what our team did, and we did some algorithms for the TDWR, Terminal Doppler Weather Radar program, did some the PUP for the DoD. I mean, there's a whole bunch of things that we built a team of 100 people that were just doing amazing things. And even the very first Vortex program was in the team that I was running way back in the day, back in the 1990s, basically, I guess it was, because in 2000 we started Weather Decision Technologies. So quite a run at the Severe Storms Lab for sure. Still an awful lot of friends there.
Well, that announcement that you made on our show was when you acquired Radar Scopes many years ago.
Yeah.
At WDT, and that was a big deal. Talk about that app and some of the other cool things you did while you were there.
Well, WDT was at first we were just the whole thesis of the business was all the great stuff we did at NSSL and the University of Oklahoma. We licensed all that out to our companies. So for the first 7, 8, 9 years, we were just a back end to most of the other weather companies. We provided these, real-time radar, level 2 radar, and skit kind of algorithms and TVS and all those things to the private sector, to television, those kinds of things. And then in 2011 or so, we decided we need to be something different than that. There's only so many weather companies you can partner with. And so we acquired RadarScope with the help of some investors that we had. And RadarScope is still, mine and thousands of, maybe tens of thousands of people's go-to app for severe weather and radar, obviously. And still good friends with the developers and the team there. There we go. I would guess every single person here has RadarScope on multiple devices. But it's a great app, and provides a great service. But we also we at the same time we did RadarScope, we launched what we called Weather Ops, and that was focusing on helping customers and do outdoor events was a big thing that we did, especially after the Indiana State Fair. Jumped in with Event Safety Association and really partnered with them. And we did a lot of outdoor events, and WDT acquired by DTN, and DTN still does a huge number of outdoor events to support the for weather safety, but a lot of it was oil and gas and offshore operations, any outdoor operations. We built basically a software as a service offering along with meteorologists in the back room to talk to somebody when crap hit the fan, if you will. So it was exciting run at WDT for sure. And I thought we built a company that was providing a great service to many of our customers and partners for sure.
Y'all had a weather radio app while at WDT too. What happened to it, Mike? Is it still out there, or have y'all deprecated it over time?
It got overtaken for a long time, though. It was like the app. What we did end up doing was white labeling it to very for like 250 local television stations had it white labeled basically with their name on it. And at some point, that all just kind of filtered away as competition changed and the world changed. But that was a great run too. You know, Weather Radio was a app that alerted you of in the polygons from way back when, right? But it was a free app, and I'm not sure we ever made a lot of money on that, but we had a lot of users for sure.
Yeah, just getting a one-time fee at the beginning doesn't make a very stable business model.
Right, exactly.
I understand that very, very well. So, WDT was acquired by DTN at some point. Talk about that transition and what you got to do over there, Mike.
Well, when I went to DTN, our investors had, they timed out basically, and they wanted to exit. So we went through a process, and DTN was the best and highest bidder for us, but mainly the best partner for us going forward. And I went into our team of 100 or so at that time went into DTN, and we took on running all of weather in DTN, and it was actually another fun time because we acquired Medio Group, the largest weather company in Europe, was actually acquired just as we were coming on. We acquired the largest weather company in Australia, Weather Zone, and we acquired four other companies too that were kind of weather and ag combined. So we did a roll-up strategy. So in a 2.5 year time, we were just adding new companies, customers, and trying to integrate all that. It was pretty wild, honestly. And I was all over the world, literally. I know my wife kept count, and I traveled 52 weeks in a row in 1 year somewhere. So it was pretty crazy, but it was a great run. But it was over. A new CEO came in and didn't want to be really in the weather space as much, and so we agreed to disagree, and I left DTN and spent a year and a half or so being a consultant to a whole bunch of small weather companies and help them raise money, help them think through strategy, help them sell themselves, all those kinds of things. And Inspire approached me, I guess, about a year and a half ago now, in December of 2022, I guess, is when it would have been. And then I joined them in January 2023. So about 15, 16 months ago at this point.
So talk about what your job is at Spire, and then we want to get into, how you guys are doing what you do.
Sure.
And all that. But talk about your role, Mike.
So we have 4 business units inside of Spire, and I run what's called Weather and Climate. So it's a team of a whole bunch of PhDs and others that our goal is to take the unique data we get from satellites and create differentiated products in the marketplace. So just think of, we can go into it further, but my job is to basically manage that team and think through products and strategies around better global forecasts, better high res forecast and other things that we do, but just sorting through the details of managing another company, basically another business unit, but this time with a little bit smaller, but significant number of employees and significant number of amount of revenue with this business too.
Well, Mike, Dr. Neil Jacobs can't wait to get into all this discussion. So I know he's champing at the bit over there. Just define one term for me before we get into the discussion here, and then I'll let him kind of take over for a while. What is radio occultation? Such a cool sounding word. It sounds like it's going to be on everyone's tongues here soon.
Well, radio occultation is a process. So think of we have 100 satellites floating around the globe at all times, right? And we're listening to the GPS satellites that are constantly transmitting. We don't have any transmission on our satellites, so we're only listening satellites. And what we're listening to is the GPS signal that's coming out. And what's cool about this is that as the beam goes through the atmosphere, it's called radial occultation. It's bent by temperature and humidity. So we can back out temperature and humidity profiles, so temperature, humidity, and pressure from that bending of the beam as it goes through the atmosphere, which is just amazing, right? So think of 100 satellites looking at all of the beams that are coming off, or all the transmissions coming off the GPS satellites, and we can measure temperature and humidity profiles, and we get about up to 10,000 a day, all dispersed pretty evenly over the globe. So in addition to balloons, 900 balloons or so that go up, we have another 10,000 profiles in the atmosphere every single day in our arsenal of technology to use.
I've got a ton of questions. I know you know the answers to these, but I think for the listeners, GPSRO, super technical. Everyone has GPS. They know what it means. It tells them where they are. But this idea that you can assimilate bending angle into the model, it's not the greatest analogy, but I've always used the analogy of you're looking into like a glass of water and the refraction kind of bends it. To me, it's amazing that you can extract useful information out of that and get a vertical coordinate on it. But one of the things that I think a lot of people don't realize about GPS radio occultations is that it doesn't have any bias. It's in the data assimilation world, it's what we call an anchor observation, and we can use it to bias correct other observing systems.
Right.
Which is pretty handy because when we do data denial experiments, when you pull out the GPS-RO data, the impact of other observing systems goes down. So it's really, really important. Can you talk a little bit about the orbits, the positioning, like where do you have these deployed? Where are you downlinking the signals? Like what is the process? Actually, let's take it back a little bit earlier. Like talk about like building a satellite and what goes into launching stuff into space.
Well, it's one thing that's really interesting about Spire is we've been around for 12 years now, and we design, manufacture, test, prepare for launch satellites ourselves in our Glasgow, Scotland office, right? And so this is not like we're just asking somebody else to build them for us. We actually do all that work ourselves. Then we typically put them on a SpaceX or a Rocket Labs launch, and they get pushed into space. And these things are small. They're 3U, which is the size of a large loaf of bread, basically. They're not large satellites, and they open up a solar panel once they get in space, and we don't have any propulsion on them. We can kind of turn them a little bit to get them to do a little different things, but it's amazing how simple but complex they are, if that makes sense, right? They're tiny little things. They're flying around the Earth every 90 minutes or so. They're at about 500 kilometers height. And then they're just listening. We're just listening, and I do radio occultation is exciting, but the other thing is when the beam of the GPS bounces off the ground, we can actually get dielectric properties of the soil, so we can back out soil moisture, which is a whole nother thing. And over the oceans, we can get the roughness of the waves, so we can get wind, ocean wind speeds basically. And over the ice, we can measure altimetry of the ice. So there's so much, and then even space weather is a big thing right now, right? And when it goes through the ionosphere, we measure total electron content, and so all that data becomes really valuable to different components of our customers, and as we build our own global models and high resolution models.
I want to come back to some of the new additional satellite data capabilities you're planning on rolling out, but talk a little bit about Spire's models, the value add, the impact of your data, and then also the relationships with sort of the government agencies and the national Met centers.
Sure. So from the very beginning, we've sold our data, a portion of our data, the RO data, to the National Weather Service, to ECMWF, through some other people that actually pay for it, but it goes into ECMWF, into those models. There's been numerous data denial studies, as you talked about, that show the value of, especially during COVID when airplanes were not flying, we offered free data to ECMWF, and there was this, there's like hockey stick up and down, for the 5 months that we gave them data in the quality of the forecasts, and so that's exciting to show the value of it. So today we do sell, like I said, we collect about 10,000 profiles a day right now. We sell roughly half of that to the government centers, then we keep half for ourselves, basically to run our own models. And today we run a global model. So it's a UFS, which is very similar to GFS. And we have similar but slightly better skill and accuracy than the GFS model, with our own unique data in there, and similar to the ECMWF forecasts. But what we're really excited at this point now is we've learned that we can take our RO data and put it into a high-res model. So think of HER. In fact, to make another announcement, Bill Murray, next week we are launching our CONUS HER, which goes out 6 days at 3 kilometers resolution, the exact same resolution and locate and region as the HER model, but it goes out 6 days instead of 2 days basically. We're only going to run it twice a day, but it's going to go out 6 days. And I've already run that. Have it very similar over Western Europe. We've been doing that since October, November timeframe. And we're seeing is that with the RO data, we actually get skill all the way out to that 5 or 6 days above and beyond, say, ECMWF or GFS, right? And it's because we have unique RO data, we have our unique soil moisture data going into those, as simulated into that. And I have to call out the team that we have, the team of PhDs that have done all this great data assimilation work and changed the models themselves to do that. It's an amazing team of scientists that have created this capability, but it shows that unique data coming from space can really add value, even down to these 3-kilometer runs going out to a few days. It's amazing.
Well, Mike, just a warning to you, on show 808, James spent the rest of the show beating Chris up, trying to get him to give us a discount so we could use the model. So I would expect that barrage to come anytime. Back to you, Dr. Jacobs.
Oh, your comment reminded me that I didn't know there was a competition at NC State between the students and the faculty that were doing the annual university forecast competition. And I had some students in my thermodynamics class come to me and start asking me like what a lot of the Panasonic models were saying about various things. And I just gave them the output because I didn't know. And they ended up, I think the deal they had was if they could beat the professor, they would get an A. And I got this call. They're like, "Are you sharing data with the students?" Anyway,
did that disqualify them, Dr. Jacobs?
No, because I didn't. I mean, they still had to. I just gave them the output files. I mean, it might have even been like Grib 2. They would have had to have plotted it for all I know. So can you talk a little bit, Mike, about the orbits and things like that? Like where, one thing that I think people don't realize is, it's intuitive to think, oh, we got this CONUS domain. Everything's coming from west to east. And obviously, the further you observe things to the west, the longer you can forecast duration in the east. And then once you have a global model, just going in circles. But with the exception of like the radiosondes and some aircraft data, there's not a lot of stuff between 0 and 12Z in the middle and upper troposphere. It's really nothing except for satellite data. And there's really pretty thin on vertical profiles. So talk a little bit about kind of the strategy of what orbits you place these in to try to maximize the impact of the data.
Well, I mean, I don't know if it's, what it ends up being, but you're absolutely right. First of all, having data over the oceans where there's very little vertical profiles, especially, is a very unique capability, right? And our data assimilation grid for our high resolution model goes way out over the Western Pacific, and the one for Europe goes all over almost all of the Atlantic to provide that data. But the unique part about our satellites is they're zipping around the globe every 90 minutes or so, and they're collecting data in kind of a random spot, really, right? It's random, but if you show a picture of it, it's a whole bunch of dots, and it kind of covers up the whole globe, right? And from the poles all the way, to the equator and over all the oceans are just as dense as they are any place else, right? So it's very unique to have all of these profiles coming in and on a constant basis. So when we run every hour or every 3 hours or whatever, we have new unique data coming in from our satellites on a regular basis. And that's what's exciting for us, is that opportunity to have all that unique data and the team that knows how to utilize that data. Because it's not trivial. It's not just a balloon sounding, that you get in. You have to do a lot of work to pull out and extract temperature and humidity profiles from it. But our team has done that, and they figured out how to utilize it best for data assimilation. And you're absolutely right. When we start talking to ECMWF and National Weather Service, the value of the RO data is more than just the RO data itself. It's the way other data are calibrated against it, so that what's the saying about rising tides lifts all ships? That's basically what we got going there.
It's interesting that you mentioned that. Like, what has been kind of the journey for the transition in the weather enterprise? Like, maybe put on like your weather enterprise AMS hat here for a second, because for years, as long as I can remember, all the satellite programs were basically NOAA, NASA, government run. And now I think we're seeing this paradigm shift where there's commercial data, there's CubeSat companies producing this information. What's sort of your view of the current and possibly like prediction of the future of like the public-private partnership relationship? I mean, you were in the weather enterprise back when the Fair Weather Report came out the first time. I mean, I think things are a lot different now, but we really haven't gone back to that to reanalyze where the swim lanes are and who does what. What do you think the commercial satellite data business is doing to that business model and that relationship?
Well, I say it's rapidly evolving, right? And everybody's trying to. I mean, I think anytime that anything rapidly evolves in any industry, there's a lot of consternation. There's a lot of people pushing back on it. Some people are excited by it, and I think we're seeing that in this case, where we are working, Spire and our somewhat competitors, but others that are producing EO data, Earth observation data. It's trying to figure out what is the business model that works for everybody. And so it's been an interesting battle, honestly, to try to figure out, in a perfect world, somebody would tell us, hey, we want to buy 10,000 RO profiles for the next 5 years, and then we can go launch all the satellites we need to support it. But in today's world, it can be here's a 6-month contract, and oops, we don't want to buy it the next 6 months, but then the next 6 months we might, for example. But we can't park those satellites, right? We can't say, we're just going to park them. In fact, after 3 to 5 years, they deorbit and whatever. So from a business standpoint, I think we'll work over time to structure deals that are good for the government and good for the private sector. But we're definitely seeing a lot more investment, right? Investors are coming in, more and more companies are launching satellites, more and more companies are working towards RO and what we call GNSS-R, which is observing the soil moisture and those kinds of things. But I think we're still a few years from an equilibrium, if you will, and until we all kind of figure out sort of how we're going to work together, what really, really works for all parties involved.
What do you think comes next after GPSRO? What as far as like the CubeSat industry, like what do you think the next capability is going to be?
Well, Tomorrow.io is doing some interesting stuff with kind of radar from space. We're working on a hyperspectral capability, which allows us to detect. We were already doing polarimetric radio occultation, which allows us to do sort of the HV, and we can get humidity from that better. But now we're going to HIMS, we call it, hyperspectral data, and much bigger satellites now. Now we're talking about 16U, so the size of, say, a college refrigerator you used to have in your room, in your dorm, if you remember that, about that size. And so there we can now actually measure moisture. It's kind of like radar from space at that point too. We can see clouds, we can see the moisture in the clouds and those kind of things. So definitely on the satellite side, I think we're going to see more and more different kinds of data, but each one takes significant time to figure out how to assimilate into models and create value from them. And so for us, hyperspectral is the microwave is the very next thing that we're going after.
That's going to be a game changer.
Absolutely.
For those who don't remember the microwave hyperspectral imagery kerfuffle that I got in with the FCC about 5 years ago, that'll be an ongoing battle because radiances for water vapor only occur where the molecule decides it's going to happen, and we can't change that. So real quick, I'm going to hand it back to everyone else. So you're running these proprietary models, you're generating a lot of different output that you would normally get from the publicly available models because you've got full control over all the different variables and time steps and everything else. Like what sort of level of customization can you do, and what sort of like products and services are you offering?
Well, we're running over these two key places in the world right now, Western Europe and the CONUS, and you can produce lots and lots of output. But I'm going to use your question to segue into artificial intelligence, because I think there's a whole nother avenue that's happening right now where physics-based models have been the thing for all of our careers, and all of a sudden in the last year and a half, 2 years, there's this thing called artificial intelligence, and all of a sudden ECMWF started a team and they're investing in it, and their new AI model is comparable or even better than their physics-based model, right? And but we view the world from a Spire standpoint is, in the past, the person with the biggest computer kind of won, right? They could crunch the most data, they could run a lot further, and so Spire's not going to buy an 80 million or $100 million computer. That's just reality of life, right? We're not going to chase down to 5 kilometers resolution globally. We just can't as a private company. However, in the AI world, once you train the models, you can run a global model out to, say, 20 days on a single GPU. And that changes the absolute paradigm. And that paradigm now becomes, maybe we could do 100, or maybe we could do 1,000 ensembles every hour for our customers. And it could do wind forecasts at hub height, or you could just think of through different things. And so we made a big announcement about 2 months ago that we're collaborating with NVIDIA on building out an AI model using our unique data as a starting point. And so all of a sudden now, data is a differentiator, not the biggest supercomputer. And so we're very excited about that opportunity where we can customize forecasts. We can support data scientists that no longer get 5 ensembles or 8 ensembles or even 50 ensembles, but they can get ensembles that cover every single possibility in the future. So hundreds of ensembles on a very quick updating basis. So that's what we're excited about right now, and really going after that.
So I know Neil has other things to ask you. We're going to hold him at bay for just a minute to get on to other topics. But I know one of the things that our audience is really thinking about right now, because of what's gone on over the last week, is space weather. And believe it or not, what you're talking about, circling the Earth in 90 minutes, being at 500 kilometers or so, is actually considered low Earth orbit. This is fairly close to the Earth compared to some other satellite systems and things that are possible and run. So I'm first wanting to know from you if you can talk a little bit about what can happen when satellites are in low Earth orbit. Can you describe for our audience what satellite owners and operators might have been concerned about this week? Maybe your constellations, maybe others, but what was going on?
Well, there's 2 things that happen. One is you always worry about control of your satellites and other things, and you can lose touch with them during a big magnetic storm. But the other thing that actually bothers the whole industry right now, the low Earth orbiting, is the number of, just as the solar peak that we're going through, and these 1 or 2 day events aren't that as important as we have the solar 11-year cycle or whatever. it's making our satellites deorbit faster than expected or faster than we want them to. And so just a few extra electrons basically in the atmosphere just hits our satellites, slows them down a little bit, and makes them start to deorbit faster. So there's everybody in low Earth orbit space right now is worried about that for sure. Is, what we used to think was a 5-year history might be only 3.5-year life cycle of our satellites, for example. And so that's the biggest impact. So we need to launch more satellites to keep our 100-yard constellation. Yeah, solar drag is basically slowing me down. I just saw a chat saying that, but that's exactly what's happening.
Yeah, and I noticed you said earlier these little bread box sized satellites, they don't have compulsion systems. Is there anything you can do, or are they just kind of at the whim of what happens to them?
They're pretty much at the whim. We can kind of rotate it by, we have these solar arms, right? They're like wings, and we can actually put it what we call Superman mode. Just think of it, it's flat. We can put it in Superman mode and they last longer, but we can't collect data when they're in Superman mode. So we have done some to try to maximize out for longer time periods. We put a few into Superman mode so they will stay up longer until others burn, deorbit basically and do that. So we're playing a lot of interesting games to make sure we have a constellation up there of a size that we need to meet our customers' needs.
Yeah, it's so interesting. I was flying home from Wisconsin. I was actually helping to do the science review for one of the satellite cooperative institutes, SIMS, up in Madison, and I flew back during the sort of peak of the solar activity, the G5 event. And I was watching satellites as I was flying along, and I saw what I'm positive I saw a CubeSat fall out of orbit because I was watching a constellation. It was clearly a constellation going by. There were periodic, little satellites, and it was just really jarring, I think, to sort of feel that, like, oh my gosh, we're adding so much to low Earth orbit, and we're putting so much of our trust in these systems to run things on Earth. There's conversation about CubeSats being the way that we do some of our international diplomacy, that it's going to bring, internet to portions of Africa that have never had access, and all kinds of things. And when you think about putting these things into those really important positions in a country's infrastructure, we have to make sure that we can manage them and that they can be secure and reliable. So I'm curious, from your perspective, running systems in low Earth orbit, can you tell us about even the state of the science? What do we know about the physics of the low Earth orbit of the atmosphere? Is there, in some sense, a big commercial enterprise that's flying around in a part of the atmosphere we haven't really observed a whole lot before?
Well, I'm probably not a great expert to answer your question, but I've rubbed elbows with a lot of experts over the last year for sure, and it's amazing the operations that we have a whole 24-hour set, 24/7 team that's worried about operations. We are doing, we have 35 of our own ground stations around the world that download the data, and we have another. We buy ground station data from or ground station capabilities from other people too, so we can supplement what we can collect ourselves. So it's a highly complex operations, and we have forecasts of where satellites are going to be and when they will deorbit, months or years in advance. We are tracking every single satellite, and this team is 24/7 worried about the data coming down and making sure we're getting it down and to our customers. It's a very, very it really is rocket science, right? I mean, it really is. And it's a very, very complex process that Spire does from end to end.
It is. And I recognize my question is a little bit unfair because you can't necessarily answer the question, and neither can most anyone else. The reason is because there hasn't been a whole lot known about the environment of the low Earth atmosphere. We haven't done what we're doing today, flying these constellations of CubeSats, until recent years, right?
Yeah,
and
absolutely.
So go ahead.
Yeah, it's amazing though how well that we can we can predict exactly where our satellites are going to be and when they'll deorbit. Months in advance, we know on Tuesday, March 15th, that satellite's gonna deorbit, and it's based upon space electron content and a whole bunch of other stuff. But you're right. I mean, we really haven't observed from that and higher in our atmosphere at all, really, in modern history, right? It's still a big unknown for sure.
Yeah, and I'll pass this along. I know there's a couple of other questions folks are brewing on, but I really appreciate, I think, the innovative. I mean, it has to be, I would love a personal reflection from you. Like being at this frontier, what is it like to work at this interspace of terrestrial weather and space? It seems like such a neat group of people that you do get to rub elbows with, and probably stretches your scientific knowledge and imagination in so many ways. It's almost like a new kind of science and application is being born.
Well, it's been amazing. I always consider myself a radar guy, right? And a sphere storm guy. And all of a sudden I'm thrown into satellites and space and had no idea that somebody could design and build and launch. And I felt for the first 6 months as Spire that I was just learning what is a satellite, how does it work, how does the RO data collected. But the part I didn't know was working with the team that were directly reporting to me about how we can utilize that data and how exciting that was. But I'll just say the number of really, really, really smart people, the rocket scientists in this company is amazing. There's 400 and some employees, and it's amazing what they have done and what they are continuing to do to extract the most data out of our own constellation and keep launching. I think we're just launching. We launch 6 or 7 on every satellite that goes up. Every satellite we can find right now, we're launching 6 or 7 satellites because we need to keep replenishing our constellation. But each one that goes up is better than the ones that were already up there, right? Because we constantly make them better. So it's an exciting time at a place like Spire, where we're not only doing great things in weather, we're actually tracking every single ship on the globe, whether they want to or not. We can see the dark ships. We track every airplane in near real time too, using our satellite constellations. So we're doing a lot of exciting things with the satellites for sure.
Bill, you're on
Bill,
mute.
you're
on mute,
talking, but we
and
can't
I
hear a
just
word you say.
realized that before y'all told me that. Doggone it. Mike, one quick question. Chris told us that one of the benefits of working at Spire is you get to name a satellite. Have you named your satellite yet? And is that, when will you run out of satellites? Will you always have more satellites than you have team members?
I'm number employee something like 600 or something like that, but there's only 400 employees now. But I have chosen a name, my 2 daughters' names as my name of my satellite. But it's a long time from now, I think, before we get to 400 and some satellites or whatever that are up there. But I hope I can stay as long as possible at Spire so that I can see a satellite with the names that I chose up there. It was pretty cool.
And Mike, we tried to get the GraphCast folks, the Google DeepMind folks, talk about some of the other efforts in AI and machine learning, and talk about the difference between those two terms.
Well, I'll start with artificial intelligence, because that is a whole new way to look at forecasting, and basically we are training. And so Google and NVIDIA, so NVIDIA's got ForecastNet, Google has the 2 or 3 of them now, and then now the ECMWF has built an AI model. And basically those AI models are taking the ERA 5, which is like the last 50 years of history from ECMWF, and they just train an artificial intelligence model to figure out what the forecasts are, and then you can just kick that model off with artificial, it's artificial intelligence trains it, and it kind of learns the physics, if you will, and then you can run forward in time based upon the ECMWF analysis, if you will, and that's the basic way to think about it. And we're just we're inserting ourselves near the end of that. We have 5 years of history of our RO data assimilated, and then we can kick forward in time with our own AI model. Machine learning is a little different. Typically, I always think of it as AI is sort of how you can produce the forecast. Machine learning is how you take a forecast and you utilize it to then predict something on the ground, like wildfire risk or solar energy power forecast or solar forecast or electricity demand or those kind of things. So very similar in nature, and you can wrap both of those into, but we kind of talk about an AI plus ML strategy where AI is creating a forecast, ML is creating a forecast of some real world problem, if you will. That's how we look at it anyway from the weather industry.
I want to go back to this tracking capability for a second because I've always found this kind of interesting because I worked in the avionics world back when that MH370 or whatever went missing, and I think people were freaked out by like, what do you mean you don't know where it went? And it used to be that, Inmarsat was like kind of the go-to satcom, and maybe they had Iridium, but it was only pinging it every 15 minutes and you could deactivate a lot of stuff. And since then, I think a lot of companies or a lot of like nations actually are starting to require like back channel secondary tracking capability. And I'm curious to know, like, what are you doing on the tracking on the aviation side, and probably also touch on the shipping side. One of the things that drove me nuts when I was working at NOAA was all this illegal fishing. You get all these vessels that come into the U.S. exclusive economic zone quite often and turn off their transponders and start fishing in our waters. And while you can see them on satellite or IR, you can't necessarily detect them with the transponder. So comparing the difference of the ship's here, but it's not telling us it's here is kind of an interesting capability. So, what's sort of the commercial model for running data to and from ships? And maybe, I guess maybe this is kind of just a curious question. Can you get weather information or stuff off the ships with this communications technology?
So I'll stick in the ships for a while, then we'll go to the aircraft later. But so in the maritime world today, we track, AIS. We can track the AIS transponders basically from space all over the globe, and so we update every ship location every 5 minutes. But we also have RFGL, radio frequency geolocation. So if a ship turns off their AIS transponder, we can actually still track them because they're always doing something. They've got sonar, somebody's talking on a cell phone, somebody's doing radio or whatever. So we can actually, they try to go dark, but we still know where they're at. And so we have a service we sell to organizations in the spook space, I'll just call it that, in defense space, where we can track not only ships that want to be tracked, but we can track ships that don't want to be tracked. And there's a whole bunch of examples you can find on social media and other places where we've tracked ships that go to Venezuela. They pretend they're stay in Western Africa. In reality, they go to Venezuela, get a load of oil, and they go drop it off someplace. And then all of a sudden they turn the transponder back on, and boom, you see them where they said they were. And illegal fishing is a whole big other area in the Southeast Pacific is a bigger problem. And as you just said, in and around the U.S. too. So the ability to do that is a very mature capability, and our maritime business basically sells that AIS data, as we call it, and the dark data, if you will, spoofing ship data. On the aviation side, we just signed a contract with the German government called Irialo, and we are there looking at how we're going to launch eventually a constellation that will track every aircraft in real time. Right now, we can track and get history of aircraft, but not as often as every few seconds, which is you really need. You need every 5 seconds or so, and that's eventually some goal. But in the near term, we can track history of ships all over the globe. But we're doing the design studies and launching a few satellites here in the next year under this Irialo program for aviation.
I don't remember if y'all remember this, but I guess maybe a couple of years ago, CNN contacted me about those red lights in the ocean where they thought it was UFOs. Those were illegal fishing vessels that were fishing for a type of fish that's attracted to this red light. And of course, they didn't show up on any tracking system because they had their transponders turned off, and everyone thought it was like UFOs or some military operation. One more question for you, Mike. Can you talk a little bit about the AMS Forecast Improvement Group? You're the new chair of that. Like, what's going on with that? Can you give us an update?
Well, I appreciate you bringing that up. I really wanted to bring that up today because AMS reached out to me last fall and asked if I would chair or co-chair the Forecast Improvement Group. And after twisting my arm a little bit, I said yes. And but it's been really fun. There's a great group of people on the team, on the executive committee, as we will. And we kind of decided to position ourselves right away into this artificial intelligence versus NWP game. And we had a town hall at the AMS annual meeting in Baltimore in January, and it was heavily attended. 350 people showed up, and we had a panel session, and that panel session was just 4 experts. We had a guy from NVIDIA, we had a guy from ECNWF, a guy from NOAA, all the experts that were working in those fields in AI. And we didn't do any presentations. We just had Q&A the whole hour and a half. And we had to just finally shut it off. We tried to go an hour and 15, it went an hour and a half. And it was an amazing conversation in the community. It's like the one thing right now where everybody's debating is AI going to take over the world? Do we really need to do NWP? And people are asking questions like, well, do we need to do science experiments anymore if AI is just going to solve all the problems? Do we even need to understand physics anymore at all? And so it's just a big debate, right? And I'm just do a quick little plug. We're going to do another virtual version of that same town hall here in about, we haven't picked the exact date, but either the 3rd or 4th week of June. And I'll pass it to the WeatherBrains team here too when we have it. But same kind of, we're going to have a different panel session, different set of experts, but the same idea is no presentations, just Q&A from the crowd and let the games begin. But there's very passionate people. Some people believe that AI is going to take over the world and we all lose our jobs. There's no reason to have WeatherBrains ever again because AI will just do it for us. And then there's others that believe that NWP is always going to be that, and AI just needs NWP to sort of help tweak things. But obviously, the real answer is probably somewhere in the middle of that. But it's a great debate in the community right now. And so we positioned the Forecast Improvement Group as sort of that group that's just trying to bring people together to have that conversation. And it's been a lot of fun, honestly.
Well, Mike, we're not worried at all about losing our jobs to AI here because we're the antithesis of artificial intelligence. We are fake intelligence. So, James, on that note, take it away.
Yeah. So Mike, where do you see forecasting in 10, 15 years from now? Just your personal opinion. You're in with all these people. Where do you think this is going in 10 to 15 years?
I think I need a glass of wine just like Neil has right now. A good thing. It's a huge debate, honestly. I do believe that AI is going to dramatically change the way we think about forecasting, and I think it's going to make a huge difference. But no matter what, we have to do all the physics-based models. That's how you train the other models, right? And to train the AI models. There's some people believe that you could just give all the data to an AI model and you don't need any physics. I don't believe it's going to go that way. That just seems.
Well, how would that work?
Just like it's like here's the data, here's what the results were. AI figured out for us. But some people are trying that. Google's trying that right now. They're trying to figure out to not even use Era 5 is all the physics analysis. They're just saying here's all the raw data. Figured out AI model and produce a forecast for me. And that seems like quite a stretch, but that is people are trying that. I think it's going to be a mixture of the two. But I do think that the number for data scientists and for those kind of people, the ability to do 10,000 ensembles on a regular basis will change how we can even think about the possibilities. Those tail forecasts that we never even, you say, hey, it wasn't in the 50 Jeff's forecast, right? All of a sudden, if you have 1,000, almost every weather variable, it'll be in that domain, if you will, of possibilities. So I don't have a great answer for you. Like I said, wine would help maybe, but it's going to change dramatically, I think, over the next few years. And for 10 years from now, it's really, really hard to even envision what it's going to be.
And the big question, you got a high school kid right now. Maybe he's, 15 or 16. He loves weather with a passion. He cannot wait to get to college and learn meteorology. He wants to do this. What's the human? Where do humans fit in 10 to 15 years?
Well, I've always believed that having smart humans in the loop, so experts in the loop, creates significant value. And when we've seen it, hell, the National Weather Service does it, the private sector does it. When it doesn't really matter when it's 72 degrees and sunny. Honestly, none of us really create any value in that at that time. It's when there's severe weather and tornadoes and hurricanes and all that, because even if the models were perfect, the impact of the models are not perfect, and the models aren't perfect, right? And so the private sector are helping people make decisions around, do I move that billion-dollar asset floating in the Gulf of Mexico when the hurricane's coming? Do people do they take cover? Where's a tornado warning, imminent tornado warning? There's so much that the humans create and will forever, right? I mean, that's just a great add-on. We never will take artificial intelligence, and we no longer have a National Weather Service forecast office, for example. We'll never, I just don't believe that's going to go that way. I think there's still always value to have color commentary, if you will, around all the great tools. But we'll all get better because the tools will be better, right? And that's just what we've done as we've seen through our careers, is the tools get better. So our forecasts get better, our warnings get better, and our ability to add color on top of that still creates significant value.
Well, I just can't wait until AI can help me tell people at 7 o'clock in the morning where we're going to have random air mass convection at 3 o'clock that afternoon on a hot July day down here. When that happens, I know that it's working. I mean, that is the greatest mystery of weather down here. And I know we got to go to Bruce Jones here. We got some other things we have to do in a second, Mike. But so let's just get real here. So I get a lot of my model data from Weather Bell.
Yep.
So I click on Spire Enhanced, and it says, talk to a weather expert, contact us. So I would assume when you come out with this 6-day HER, if we can access this through an interface like WeatherBell. Is that correct?
Yes. It's frankly, it's GRIB2 data, just like any other model output. And so it can plug and play right into your television display or whatever. And I'll make you a sweet deal if you want to have it. But
yeah, all right, that's what I'm talking about. Yeah, I will plug that thing right into that old Baron box. Yeah,
I was warned that you were going to ask for a deal, but yeah, happy to have you have a deal. But I think it basically is a HER model going out to 6 days, and I think adds significant value in days 3, 4, 5, and 6 above the HER for sure.
And let me just say too, I mean, as a plug here, I mean, you get the basic tier, the data suite with the WeatherBell subscription now. It's there.
Yep. And you get the global model.
This is very what I've learned tonight. I have learned the value of what that is and how important that is just another item in the toolbox. And goodness, the more data we can have in the toolbox, the better off we are. So anyway, but we're going to take a quick break here. And Mike, can you stay with us for a while longer?
I can stay as long as you want.
Yes. All right. Excellent. So we want you to come back with a good pick of the week here in just a little bit, but we're going to take a quick break. And Jen, I think we're actually going to do a little email segment tonight, right?
We are. I've got a couple pulled here, a little bit of a longer segment.
All right, very nice. So what we're going to do, we're going to take a quick pause here. I don't see a report from Tony this week, so we're going to do Jen in This Week in Tornado History, and we're going to come right back with a little email, and we got picks of the week and much more as WeatherBrains rolls along.
This Week in Tornado History. When we think of Gerald, Texas, and tornadoes, we immediately remember the devastating F5 from May 27th, 1997. But 8 years earlier, on May 17th, 1989, the town was hit hard by an F3 in the middle of the night. It developed at 3:02 a.m. Central Time, about 3 miles south-southwest of Gerald, near Strickland Grove. The tornado moved to the north and northeast and paralleled I-35, where it turned over about 18 trucks. Traffic was halted on the interstate and other roads because of all of the debris. The tornado proceeded north and then northeast over the town of Gerald, with most of the damage on the south and east side of town. 35 homes and 12 mobile homes were heavily damaged or totally destroyed. 16 business structures, a 12-unit apartment complex, and 2 school buildings were destroyed. The debris from the town was scattered northeast over the countryside for about 7 miles. One woman was killed in her mobile home when it was demolished. She was found crushed under the debris and a waterbed. 28 people were injured during this event. We document this Gerald event and hundreds more on our website at tornadotalk.com.
Let's dive into the email inbox for the first time in a while and see what's in there tonight.
All right, I've got 4 picks for tonight. Thank you, everybody, for your patience. It's been such a busy go of it for a while, but wanted to get some emails done. And the first one is from Steve Holmes. He wrote this in early May. And just wanted to throw this out here and get some discussion going on. At this point, when he wrote the email, he was looking at the National Weather Service in San Angelo, reporting a confirmed large and extremely dangerous tornado in Coke County, Texas. And he tried to find live coverage and was having a hard time, even on Facebook. And just wanted to see, is this a trend that some stations are not doing wall-to-wall coverage, some are doing spotty coverage? You know, what are you guys seeing as a trend with the coverage?
My opinion, I think most stations are still doing aggressive long-form coverage. The problem is it's these crappy websites. They're horrible. These corporate websites, you try and find a live stream, and it's like trying to find a needle in a haystack. You know, it ought to be easily available up front where you can click one button and it's live. And you know, it's just, to me, that's a problem. But I think most stations are still live. But this is a Texas thing down there. Troy, what's going on?
Well, I agree with you completely. I've seen some websites where I just scratch my head and say, who in the HELL has put this together? They want the public to be able to understand it. Now, not that I'm the fastest brilliantino with the web, but at the same time, I need to be able to figure out, you know, live video or live cast or live programming. It's not hard to figure out. So, you know, put that on there, make it easier, and maybe you get more viewers. I understand clicks are important these days.
Hey,
And
don't forget you get to enjoy a pre-roll ad too.
Yeah. Yeah.
Oh, yeah. Yeah. Get a, you know, Axe body wash ad before the weather.
Yeah. We'll go back to that live tornado after this Axe body ad.
Yeah. That's right. But in a lot of stations don't stream on social media because I guess they want you to watch their proprietary stream so you can watch the crappy pre-roll ad.
Well,
but
yeah.
To me, when you go into a weather emergency, it doesn't matter how people watch. Put it on everything. Put it on Facebook. And to me, you should be everywhere. And yeah, I just don't understand it. But again, so somebody needs to come up with a redo of these websites. And goodness, trying to look at a news story, it's like digital graffiti. You get these pop-ups and all this stuff, these spinning things. It's like, really, you're about to have an epileptic seizure just trying to use something here. I mean, I don't understand that. So anyway, I'm sorry, Jen. I hijacked the question.
No, that's exactly. I think that's what he wanted, was everybody to weigh in on that one. Thank you, Steve, on that. And then this one came in from Autumn Smith. Is a modular home secured to a permanent foundation considered as safe as a site-built home in a tornado, or is it the same as a home on pillars with tie-downs? This may be more toward Rick.
Engineering question.
Or
I think Rick Smith. If anybody, Rick is our expert in the field.
I'm not the expert in the field on this, but I don't know. I mean, I would have to really see it, and I'm having a hard time visualizing it. But well, I mean, it sounds better than just a mobile home sitting on concrete blocks or anchored down with straps. But beyond that, I'm not sure.
Yeah. I'm thrown by the word modular, and those are fine places to be. Except, you know, it's only as good as it's going to be secured to that foundation. And I can, in that case, Rick, think that you're going to be looking at a permanent structure that is at least pretends to be tied to a foundation. Rick, you and I've seen them a couple of times where I've seen homes totally gone. You're so impressed until you figured out that house was never tied to those cinder blocks that were down below it. And it just, you know, no wonder it disappeared. But yeah,
We've
I'd be a
seen
little
that on
leery.
recent surveys in Sulphur, Oklahoma, the EF3 tornado, bunch of destroyed houses, but they're just sitting on cinder blocks with gravity.
Gravity, yeah.
Yes. All right, we're going to put rant mode back on for the next question here. This actually was a question that came in a couple of times on email, and the last one came in from our friend Johnny Parker. I want y'all's opinion on what is considered a bust for a severe weather threat. To me, in my opinion, a bust is when absolutely nothing happens during a severe weather threat day. That could be hail, damaging winds, tornadoes. It seems like in the weather community, though, a bust is when you don't get a certain number of strong tornadoes within the specified risk zone. I can go into a whole rant on this subject, but I won't, but we might. So,
well, no, and the whole thing is cool off, people. Stay off social media. Don't be hopping on weather. I'm as critical of the Weather Service on some things they do. Sometimes just silly, but at the same time, after one of these events, don't be sitting there in social media and tearing up your local Weather Service office. Please don't do that. Yep. That's my rant.
I think a bust is in the eye of the beholder. I mean, it depends on what you expected, what you did based on the forecast, what you thought was going to happen, what they said was going to happen. I mean, it's variable. I mean, to a sane person, nobody's going to complain that there's no destructive tornadoes that happen during an event, but there's not everybody like that. Not everybody's like that on social media. Surprise, I know.
I've looked at a lot of this stuff, and it's very interesting to me, particularly with winter weather, not so much convection, but busts tend to be in the eye of the beholder. And when you have people that, these snow geese out there that want 3 feet of snow in their yard, and it doesn't materialize, say they only get 30 inches or something. They're mad. And other people who, it's like their next door neighbor who might hate shoveling snow, thinks that was a win. So I think you need to factor in what people actually want out of this too. I mean, that's going to add a whole new layer of AI complication.
Well, but I'm not really frankly interested in what people want.
No,
I want to see that. I want to see that I don't know what it is. I don't know how you answer that question necessarily in a way, because I agree completely with what Rick said, but I just can't believe some of the social media crap that I saw in the last couple of weeks coming down on some weather service offices here in the country is inexcusable.
Well, I can give you a mathematical equation for at least what the medium range folks consider a bust, and that is an anomaly correlation coefficient of 0.6 or less. Somehow or another, they determine that a useful forecast is 0.6 or higher, which in my mind, I guess maybe 0.59 and below means it's useless. I don't know how they arrived at that term, but if you look at something called useful forecast skill, it's AC scores of 0.6 or higher. So that's your official definition. I don't know what you do with it, though.
Someone explain to me what Neil just said. I'm kidding, Neil. I'm kidding with.
So post that on Twitter and see what happens.
Yeah, exactly.
Oh my goodness. And I think what it comes down to, weather is hard, everybody.
I like that.
It's just hard. I think about what happened last Monday in Oklahoma. It was not a bust, everybody.
No.
Tell
the
people
folks in Barnesville and Barnesville that.
Yeah, exactly. It was very difficult, and it is very difficult to get all the atmospheric conditions together to form a tornado. And it's just, there's so much that goes into it. And the messaging was so great. The potential was there. And we have to do our best to try to message it. And I'm with Troy on it. It's just, people are so quick to judge and attack. And it's annoying and not helpful at all.
And something else too, Jen, and everyone here tonight, does it seem to y'all that this spring, for some reason, the predictability has just been so difficult? I mean, I don't know whether people expect one solution for it to be a good forecast, but there's not just one solution. There are millions of different solutions. And I just don't think people understand that. I really don't. But yeah.
Well, and you have to realize, for like the people in Ardmore who had just been through a tornado the week before, when they saw all of the forecasts that morning, they were like cats on the drapery, and I was trying to reassure them, and hey, I think you're going to be okay. Nobody is more grateful than for a bust than somebody who's been through one of these things. So, put yourself in somebody else's shoes.
Absolutely.
Yeah. Amen. All right. So our last question is from James Lewis, and I think this will be a perfect time to bring in Bruce Jones. And so I'll kind of bring him in here, and then Bill, you can take over. But he has the following question: how do Amish people get weather warnings? If there's a tornado or wildfire on something, what do they do? I don't know if anyone can answer this. I bet Bruce Jones can. And I don't think there's a very sizable population in most of the areas the panel is from, so they may not know what I'm even talking about. But we do, because there's been several instances where there's 2021, December 2021, there were Amish communities that were struck by that tornado outbreak. And so, Bruce, how are you? Let's have you weigh in on that.
Well, interestingly, we're actually working on a radio for the Amish community. Mm-hmm. And in talking to Joe Sullivan and Jane Marie Wicks and a lot of smart people from the National Weather Service around the Kentucky, Tennessee area, they've been working with the Amish population for quite some time. I've learned so much. It's been a fascinating journey for me, just finding out about the Amish. It's not one flavor. There's different flavors of this, just like there's different flavors of Christianity, the Baptist and so on. Right now, a lot of Amish can use a cell phone in their business. They can't use it in their home. But if it's for the purpose of commerce and business, there are Amish families where they have cell phones, but those phones must be left outside of the home when you enter the house. And I was totally unaware of that. We have Amish people that have a little bit of copper wiring in their walls. We have Amish people who tear it all out. We have some Amish that don't want to have anything to do with any kind of a weather radio. And we have others who say, well, if it's solar powered or solar powered hand crank, we would use that. And then talking with National Weather Service, again, in Tennessee and Kentucky, they actually have some phone line numbers where the Amish can call in and get forecasts. But the forecasts need to be primarily focused on business and commerce. A business and commerce forecast, for instance, hay cutting forecast, is acceptable to the community. Some other forecast products, maybe not. It's been very, very interesting. But, when you think about it, if you're living totally off the grid, you're basically living in 1925 and the tri-state tornadoes coming at you. It was 25, right, Troy?
Yes.
These dates are starting to get
well.
These dates are starting to get fuzzy as
James,
I get older.
James.
I was on television. I remember well.
He was. I watched him that night. Yeah.
It was a wooden television.
Exactly. Yeah.
You had to stoke it with coal. Coal-fired television, and there's James.
That's in the running for the show title now.
Show title.
No, but I mean, think of it. These sweet souls. Sometimes their only tornado warning is the visualization of the funnel right in the next field next to them, and it's coming toward the house, and everybody has to run down to the cellar. So we are working on a solution for this. Right now, there are some avenues of information that the Amish can get. Of course, outdoor sirens at times can help those who are out on the farms in the rural areas, but most county emergency managers cannot afford all the outdoor sirens they need to, properly warn an entire rural county. So, Jen, great question. The quick answer is we're working on one. We're going to help them. They need help.
Well, and Bruce, tonight we've been talking about all these technological advancements, but when you talk about that last mile of getting the watch or the warning into the hands of the public, weather radio still plays a huge part in that. And you've got an offer for our listeners. Why don't you share that?
Yeah, we really appreciate what WeatherBrains does for the weather community and for anyone with any interest in weather whatsoever. And if you're part of this community, I will remind you that as part of the Weather Ready Nation, we would like you to help spread the word about the importance of having NOAA weather radios. This is the official warning system of the United States federal government. NOAA weather radio is our official federal warning system, and it's really the backbone of all of our alerting modalities. And smoke detectors are required by law in every state of the nation, but storm detectors are not. Storm detectors are required by common sense. And if you study the weather, you follow the weather, especially severe weather, you know these storms are going to happen. And if it's not weather, it could be wildfire. So every home should have a storm detector, just like every home has a smoke detector. And NOAA Weather Radio is the best storm detector that you can buy. If you go to midlandusa.com, the website midlandusa.com, there's a promo code that you can use to get 25% off of a weather radio. And, Mother's Day, we just had that yesterday. Father's Day is coming up. There's always birthdays, there's anniversaries, there's weddings. NOAA Weather Radio makes a fantastic gift because it's the one gift that could actually save lives. With the promo code SPAN25, that's SPANN25. SPAN25 is the promo code that gets you 25% off of any weather radio product or accessory at midlandusa.com. And basically, you've got two different types of radios. You've got a weather radio you can take with you as you travel, as you move about, or you could have a weather radio that you use at home. A public alert certified weather radio at home will only go off for your specific area, and that's the best way to warn you and your family that trouble is afoot. So if you travel a lot like I do, the most important thing to do is before you leave home, make sure there's a NOAA weather radio there. And that way, when I travel, I don't need to worry about my wife and daughters. I know that they'll get their warnings immediately. I don't need to pick up my phone and call them. The promo code is SPAN25, SPANN25, and you use that promo code at midlandusa.com.
Very good. All right. So let's go into picks of the week. But before we do that, real quick, let's take a peek at the radar. Again, we're live on Monday, May 13th. Pretty nasty line coming right into New Orleans. Troy, you ever been to New Orleans?
I've been to New Orleans, and that line, by the way, James, and everyone else produced a 79-mile-per-hour gust out to the west on the west side of the screen at Lafayette here as the show started. So we did the ASOS there had a 79-mile-per-hour wind gust at Lafayette.
Hey, Troy, when are we getting the Hammond radar up and running?
I thought it was up and running. I think
I did too. It's down tonight.
But I don't. I'm assuming
maybe it's
it
not
is
on
up
my
and running,
radar.
but I don't
not
know
on my
this.
radar software.
Yeah.
Maybe.
Yeah.
It's
up now.
This is what you're looking at right here. That's
Is
the
that
Hammond
Hammond?
radar.
Hammond.
Yeah. That's
wow, it's not
I
on my
mean-
GR2 analyst. That's crazy.
And
It
it's
is,
that's got to be coming through Orleans Parish and those areas, Jefferson Parish, very quickly. So if we have people watching or listening to us live down there, that is that's got some wind with it.
Yeah.
Bill,
Yeah,
I think there's
that's
an
gonna-
update you can do for that. I think he's
that's
pushed
probably
one
what
out.
I need to do. Thank you, James.
You bet.
All right, so let's morph into picks of the week. This is where we're going to go around the horn, and everybody is going to share something that is weather related, something that is very cool. And Mike, we'll stall, so we'll give you a few minutes to think about it. We'll come to you at the end here. And I will say my pick, it is little bit from the National Hurricane Center on all of the changes and updates on their products. And we are now only, a couple of weeks basically away from hurricane season for the Atlantic Basin. In fact, I saw we have a little disturbance in the Eastern Pacific that's showing up. So it's that time of the year. So again, my pick, it's going to be the Hurricane Center and their potential changes coming up. Let's go to Dr. Jacobs. Neil, what you got for us this week?
My pick of the week is, and this will probably make more sense when you see the newsletter, because Jen, you'll be pleased to know that I've written my piece in advance this week.
Yeah.
Wait, we can do that?
Making us all look bad, Dr. Jacobs.
Normally it's like 3 hours before. It's a USDA Forest Service map of upcoming cicada brood emergence. And so for those of you who aren't tracking these annual cicada brood hatches, 2024 is unique because there are coincident hatches between 17-year and 13-year cicadas. The last time they hatched at the same time, these two broods, was 1803. And to put this in perspective, in North Carolina, it's so mind-numbingly loud that you can't think. I have to go inside and put earmuffs on. It's ridiculous.
Really?
Yeah,
I want that here.
When I got to DC, there's nothing in DC. Yeah. It's like totally quiet because they had their big hatch like in 2021. But it was wild because I drove up from Florida. I get out of my truck, I open the door, and I was like, what is that noise? It's crazy. And then I had this email from on my neighborhood listserv by one of the older women who's constantly emailing about stray cats and whatever. And she's like, does anyone know what this ridiculous car alarm is? I can't seem to figure out what direction it's coming from. It was the cicadas.
The end is near.
I've been getting a disturbing number of videos, so I can play this.
Yes.
The people eating these things.
No.
Yeah. I mean, so I include some recipes in my article.
Don't do it. Don't do it.
No.
No.
There goes dinner.
Oh boy, yeah. I'm sorry. This guy apparently is 92 years old and he's been eating these things for years. But he's 92, so maybe that's the secret to a long life. But I've had people sautéing these things. They put chocolate on them, and some kids eating them, and they just suck them down like M&Ms. I mean,
yeah. I'll share with you my favorite cicada recipe.
Okay, good. That's a good tease right there. And it tastes just like what?
Chicken.
Yeah, there you go. All right, let's go to James ate a lot. James, give us a good pick.
I'm not sure I know how to follow that.
No.
Yesterday, there was a tornado south, I believe, Jimenez Mountains or southwest of Santa Fe, but a tornado at about 11,000 foot elevation. That's from Grant Tosterud, one of the meteorologists over there at KRQE in Albuquerque. Good video of the thing. And as a bonus, great video of a tornado at a Tiger Woods designed golf course close to Branson this afternoon. It was kind of reminiscent of Caddyshack, except the golfers actually went in the clubhouse instead of playing through.
I don't think the heavy stuff's going to come down for quite some time.
Exactly.
That's a classic. All right. And all these picks will be up on the website, weatherbrains.com. Rick Smith, give us something good.
I had a different pick, and then I saw Mike, and something just flashed into my head. The 1985 Nova tornado episode, which I used to have memorized at one point. Probably a lot of us did. Starring Mike Iltz and a cast of other characters, Lance Rothfuss and Lou Wicker. I still get starstruck walking by Lou Wicker in the Weather Center just because he's on Nova and Tornado. And we'll talk, and with Twisters coming out, their Toto in the 1985 Nova episode was the basis for Dorothy in the Twister movie, and Dorothy makes an appearance in the new movie. So anyway, it all ties together, but you got to go watch for Mike Iltz very closely in the 1985 Nova episode called Tornado!
Excellent. All right, so let's go to Jen. Jen, give us something good.
All right. So I was very honored to be asked to be on the Across the Sky podcast. And we had that crew on the show on episode 867. And they were just so great, and they just wanted to talk about Tornado Talk, and I was so blessed to do it because we really got a chance to dive into the stories. And so I got to share some of the stories from the 74 super outbreak, and then they asked me, what was one of the lost tornadoes that had some stories. So they were just a great group. And so I had the link. JP grabbed the second link in my email there, and that way folks can listen on any of your podcast apps.
Very good. Troy Kimmel, give us a good pick of the week.
Before I get started, I want to mention Mike for a second. Mike, thanks for being with us tonight. But I go back when Mike spent a lot of time with Kevin Clazel and a bunch of us. We did a lot of stuff in venue weather safety, and we always appreciated that, Mike. And I'm glad to see you moving on up there, and we appreciate you being here tonight. So
thank you so much.
Yeah. I wanted to, this is where I'm going to go back and mention our show 3 weeks ago, episode 953. We had Bill, our guest from Tennessee Valley Weather.
Ben Luna. Mm-hmm.
Ben and Fred and Brian and Kelly as well. Folks, last week, I actually got on the app during their severe weather outbreak there in northern Alabama, southern parts of Tennessee, and what an amazing job. I'm going to do this as my pick of the week. I want to know I want you to know their website and also know they have an app. We've talked about what the future of television is. We spent time on the show many times doing that. I think, Bill Murray, that these people are the explorers. They're pioneers of how this is going to go in the future. And I congratulate our friends. Job well done, Tennessee Valley Weather last week.
Definitely
awesome.
Davy Crockett. If we're pioneers, he's Davy Crockett.
Yeah.
Davy Crockett. All right, Bruce Jones, give us a good pick.
Well, last week at Tennessee Emergency Management, Chrissy Hurley of National Weather Service Nashville gave an interesting and kind of a mind-boggling presentation. Basically, if I could summarize it in a nutshell, we've got homes being built today that don't survive a tornado as well as homes built back in the 1960s, 70s, and 80s. Same tornado, same F2, F3, and homes built today at a much higher price aren't doing as well in tornadic winds. And it's disturbing. It's a head scratcher for me, but it's one of those things to be thinking about as you drive down the road and you want to get yourself all worked up.
Get your underwear flapping up
building
down your
codes.
leg,
Don't we have building codes that's supposed to take care of this problem?
I thought so, James. I thought we had building codes. I thought we were well beyond that, but we still have homes that are sliding off foundations because, like Troy said, they're not even connected to the foundations. They're just sitting on there, sitting on it. Crazy.
Wow.
Yeah.
Okie doke. Good stuff. All right, Mike, we have stalled for a while, and we're hoping that you give us something really, really, really good.
Well, I don't have something really good, but I'll just say that living in Boulder, Colorado, or actually Berthoud, Colorado, and Norman, Oklahoma is a hell of a difference in the weather, especially in May. And I've experienced snow and 40 degrees and 30 degrees, and all my friends back in Oklahoma are storm chasing and doing all the great things that Rick Smith and team do. I miss it. I miss the excitement of the storms and all the things that are going on, even though they do damage and everything else. That's a terrible pick of the week, but just giving you my own personal experience.
No, listen, that's what a weather dweeb does. I mean, you just there's something. And listen, we don't want tornadoes to hurt anybody or to cause any damage or severe storms, but it's just interesting. It's what we live for. It's why we're here. And it's just an intrinsic fascination that we all have. And I totally understand that. I mean, I really do. All right, Bill Murray, the floor belongs to you, sir.
Yeah, James, I'll get you to break out the foghorn because I like to hear its dulcet tones. But I do have some great guests coming up, James. Next week, Brady Harris from the Stormfront Freaks will join us. They have a new severe weather channel. It seems like everybody's getting a weather channel these days. Mark Sudduth will also join us to update us on not only the hurricane season coming up, but the work he's doing on hail. Our old friend Serena Arnold will join us on show 958 on the 28th. I'm assuming, James, that one will be on Tuesday. And the amazing Beckett Moore, Troy knows who I'm talking about.
Oh, yeah.
young man who's going to be a superstar in our field is going to join us on
Prepare
that
to
show.
be amazed. Yeah.
Prepare to be amazed is right. Cameron Nixon, James Adelot has arranged for his appearance on the 3rd, and Megan Williams from the National Weather Service in Slidell will talk about a terrible wake low event that happened in the northern Gulf that was devastating to marine interests a couple of years ago. And please tune in for that. And our latest guest just joined us today, the 17th. Sam, I hope I'm saying it right. Lilo, I've always wanted to have him on the show, and we never have. But he's going to join us on the 17th to talk about some of his research. And right now, that's as far out as the radar sees. So we'll be filling up our date book the rest of June and July here shortly. If you have any suggestions, please don't hesitate to send them here at the show, because we love getting those, especially when you provide a little contact information. And your guest booking officer will go and chase them down. And many thanks to Mike Iles for joining us tonight. Mike, it was great having you on the show again. The folks are working on your robe back here in the back. We'll have it shipped to you in a few days.
No, I really appreciate it, guys. It's great seeing everybody, and I really appreciate the conversation.
So Mike, plug away. I mean, let's go. I mean, there might be some weather dweebs like me that want to get some of this fancy model data. So how can Joe on the street get access to this? Give a website, give us something.
Well, you can come to spire.com and check on the weather side, and we've got our high resolution model. We got soil moisture, and then I'll plug the FIG too, Forecast Improvement Group. There might be one of the guys on this broadcast on that panel, but we'll have a panel where we have a conversation between NWP and AI. Look out for that in late June too. So, but come check us out, spire.com.
Spire.com. And by the way, Bill Murray, just FYI, the 17th of June will need to be recorded on the 13th of June because that's the vacation week. I will be in Baston that night.
Very good. Actually, I will take care of that.
Coming back from Baston, we're going to be up there to watch the Sox and the Yankees for a couple games, and then we're going to head to the Canadian Rockies after that, assuming that the smoke doesn't choke us off. We'll record the show for the 17th on the Thursday night, the 13th. Hopefully that will work out for everybody. But if you are new here, we're typically on the air every Monday night at 8 o'clock Eastern, 7 o'clock Central. A lot of people watch it live, youtube.com/weatherbrains, but most people listen to the audio podcast. However you consume this program, we thank you. If you want to get in touch with us, the email address, it is email@weatherbrains.com. On behalf of the entire WeatherBrains crew, I'm James Spann. Thanks for listening. Have a great week, and God bless. Great show, Mike. Thank you.
Thank you, Mike.
Hour and 45. A little bit of an improvement, not much.